Okay, hi, I'm Greg Cutter. I'm a professor of oceanography at Old Dominion University, which is a state institution in Norfolk, Virginia.
How long have you been there?
Oh gosh, I've been there 40 years. So, I'm one of the ancient beasts. Yeah. Essentially, what I should start with is that there are elements, the ocean's full of everything, but there are trace elements that are at low concentration, and these trace elements, the who cares, if you will, is that many of them are essential nutrients like iron or zinc that we humans, but also plants, need to grow. And at the same time, there's other ones that are toxic, like arsenic or mercury, or you can think of toxic elements too. And so these elements will affect the growth of plants, which then take up carbon dioxide, which then affects the carbon dioxide in the atmosphere, which then affects global climate. So the who cares part is that trace elements are essential, but they can also be toxic, and then there's ranges in between. Oh, and we came up with the name too, and we came up with all kinds of crazy names. But by the way, geo, so geology or the earth, and then traces, because these are trace elements, but they're also, so these things are like parts per trillion, but there's also tracers. Some elements or compounds or isotopes can tell you where they came from. And some of these isotopes are unstable and they decay. Those are the radioactive ones, the radioactive elements, and that provides a clock. So you can say how fast things are going. So if you do these tracers to say where they came from, and then how fast are they going, and then you couple that with the other trace elements that are stable, if you will, but you don't know a lot about them, again, like iron or zinc or arsenic or whatever, okay, that you can really have this powerful tools together all at once. The Geotraces rosette whole has 24 10-liter bottles. So right there, once you send it down and bring it back up, you've got 240 liters. But we adapted existing rosettes to then sample cleanly. And by that we mean that it's a metal contraption. It's a metal cage, if you will, into which you put these plastic sampling bottles. But there's only certain metals. You don't really want it made out of iron because we would need to sample for iron. And so you make it out of, in this case, aluminum because it's relatively inexpensive, but then we powder coat it with epoxy to make it so we can sample for aluminum. And then the pressure housings that have the instrumentation. Oh, I'm sorry. So this thing puts a bunch of sample bottles, but it also has sensors to tell us what the depth is, what the temperature, what the salinity, or the connectivity, but the salinity, the oxygen, the fluorescence, and the amount of particles that are in the water. At the very least, there's many other sensors too. But whatever, you have the sensor package, so that as we lower this rosette, and it has 24 bottles on it, as we lower it, then we can see the different water masses, the oxygen, the salinity, the fluorescence, and go, oh, we need to sample here, 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 and here. Then when we bring this package up, so we send it down, let's say, thousands of meters or a mile down, and then as we bring it up, we actually keep it moving a little bit, just really about that fast. And so the clean water, because it's a non-metallic cable, so everything above it's non-metallic, and then the water passes through the bottles, and then we close them, and we close these bottles at the different depths, and then bring those up. About 1/3 gets used on board ship to see how we're doing, and the nutrients and the salinity and the oxygen. The other 2/3, so let's say 180 liters, go home. Now that's one time. At the average we do is we send it down 3 times. And then we're doing 36 stations. Now, I can't quite do the math, but we're talking many tens of thousands of liters. No, and then there's other rosettes, and okay, so you're talking tens of thousands of liters of water come back. And so we literally start to weigh the ship down with water. I mean, it actually sits lower because we bring back that much water. And so then that's another logistics kind of thing. How do you handle all that? So we tend to use these what are called pallet boxes. Were actually developed for the automotive industry when they put cars together. So this would be a Mustang box of Mustang parts and that. And so they're pallets, but they have size. They're plastic pallets. So we've got these plastic pallets all over the deck, and you may have shown some pictures of it, but they get in the way too. But yeah, so we've got tens of thousands of liters. And then the other thing is to think about this. We're making these measurements of these really tiny low things in parts per trillion in the ocean, but it's going to be different countries. It's going to be France and Canada and Brazil, etc. But they're using different techniques and different sampling systems and that. So we got a problem. We got to make sure everybody's data can be compared. And so we started a standards and intercalibration committee that would oversee the accuracy. Are we getting the right numbers in the program? And so those are the two actually standing committees in Geotraces that are incredibly important. We can get the data to the people, but we also get the right data, if you will, by doing this what we call intercalibration.